into the problem. I think we have only 11 minutes time. We'll wind up this. So when the rod makes an angle theta, so what is the position of the rod? After some time, the rod will come like this. Center of mass was earlier here, no? Now it has come here. So it has descended. Yes, it has descended. So this is theta. So center of mass has descended. And because of that, it will have here angular velocity, omega. How the reactions forces will be. How to take the reaction forces. Now, what type of motion the rod will describe? Only pure rotatory motion, at least pure rotatory motion. So I'll proceed like this. The reaction on the rod, I think. I'll show forces on one side and the reaction, this one. So what are the forces that will be acting? Mg. And it will also have alpha. How to take the reaction forces here? There are two approaches are there. Along the rod, perpendicular to rod, you can describe. Along the rod and y-axis, or along x and along y-axis. So let me, since you are familiar with the along x, along y, I'll proceed in that way. So what are the reaction forces? So one reaction force will be up. Reaction forces, I'll show this ny, and the other reaction force okay, let's write all the equations. So what is the angular velocity? So when it descends through an angle theta, so how much decrease in potential of the rod should be equal to, so let me assume one particle also I'll give it so that things will be easy for you. So things will be difficult for you. So shall I put one particle here? Because all the time we have put only one rod. A particle of mass m also is attached. Then where the center of mass of system, I think you should not show here. I'm shifting it. Somewhere it should come here. And then how much center of mass of system? O is the midpoint of the rod. A particle of mass m is fixed at upper end. Let me add up that one. So where the center of mass of system will be? So somewhere here will come. Center of mass is different. Center of mass of the rod will be different. So 2 mg will come into picture. No? So then how much of height the center of mass has descended? It has descended a height h. Call this is h. And decrease in potential G, 2 mgh should be equal to high O omega square by 2. How to calculate moment of inertia? That of the rod, ml square by 3. That of the particle, ml square. Just I brought it so that only rod we are discussing. I can attach one particle also. So what is the length of the rod? Let it be equal to this much here. Length of the rod is what? I made L, no? No, get into the problem. So I substituting this and solving, we'll get the omega. After getting omega. Then what about the torque? 2 mg. You have to solve for omega. I'll just share the ideas. And next, 2 mg. Where the center of mass of system will be? There is the So O is this one, no? See the center of mass, where the center of mass of system will be at a distance OC. So 2mg into OC cos, the distance will be sine theta should be equal to IO alpha. How to calculate anybody? OC. I think any center of mass formula shall apply. Distance OC should be equal to M L by 2 plus ML by M plus M. 3L by 2. 3L by 4. So substituting this 3L by 4 sine theta is equal to this will be 4 ml square by 3 into alpha, moment of inertia. So I'll get the alpha. Okay, after getting alpha, then what we have to do? So on one side we have alpha, as it is describing only pure rotating motion about O is a fixed axis rotation. So what are the how to show that reactions? Already I shown that one. So I'll assume a tangential acceleration. So this is theta. So therefore this is theta, this is theta. Then I'll write the equation. 2mg 2mg minus ny is equal to 2m80 sine theta. This is along y-axis because that reaction ny has to be calculated. Then along x-axis, along x-axis. How to write? So they show that how nx should act here now. Along x-axis, any equations, can you write it? I think there's some problem is there here. What is that? Even there's a centripetal acceleration also there, no? I think that we have not taken care, because what is the state of rod? It's having pure rotating motion. So there must be a normal. Most of students do forget this. So just once again, I'm reminding this one. Now, what is a normal? A normal should be equal to omega square into 3L by 4. This is a centripetal acceleration. So is it writing this equation correct now? Even component of an also should come there, no? So this has to be modified. Why, sir? Why you are bringing in? The rod is rotating. There is a tangential acceleration. You say there will be also centripetal acceleration. But sir, previous problems you didn't took. There I took centripetal force. No, you check it. M omega square. I'm writing an here. So therefore, this equation has to be modified. So what are other forces acting? 2m an cos theta. This is what some books they have not considered as, I don't know, but this must be there. Along x-axis, what is the equation you can write? Nx should be equal to 2m an sine theta minus 2m 80 cos theta. So omega I know from here. I'll bring omega from here. I know this is alpha. Okay, this. Then what happened? The reactions is what I should work out in this method here. Sir, you said an, but you didn't write any centripetal force equation. Another method for this is instead of nx, you can assume nx along this direction. So let there be y component must be there. So instead of nx, you assume like this. Then again write equations of motion along the route. This ny also will come into picture. So to avoid that, what happened? I just took like this here. Like this, you have to calculate the reaction at the inch. So when the rod is released, no, the reactions at the inch, you have to be very careful here. So it's a pure rotating motion, that is enough. But sir, why you wrote? So now you can ask questions. Pure rotating motion, okay, this is okay. So I'll round up all the things. So what is this? This is due to what? Sir, what about this? To calculate reaction, I'm just taking help of all the resultant forces that are acting. Are you getting this one? And what is this? Conservation of mechanical energy. Because work done by the reactions will be zero, no? Only the weight 2 mg does work. So even a particle can come here. Don't think that only rigid body, I can attach a particle. Then today, what all problem we discuss, if you want, you can introduce particle at some other point and you can discuss the problem. The center of mass of system will change, that's all. If the particle not there, center of mass of the rod will be the center of the rod will be center of mass of system. Because of particle came, the center of mass got shifted. So you do have some numericals where particle will be attached to a rigid body. You need to bother the same concept. Today, what all I discuss, everything will be same. Okay, try to put efforts today's. So I give some other things. No, please do work out. These things you should work out. You should put effort. Okay, I have next class. Thank you all of you.
Wrote down, sir.
Thank you, 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 sir.
Okay, thank you all of you. Take care. Bye. See you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yes. When string is cut, first translated, rotated, afterwards only rotated. That's what happens here. Yeah, that'll be right. When the string is cut in that problem, first translated, rotated, then only rotatory. Okay, I'm fine.